This video is designed to show you how to use the z-table that's found in Appendix A of your Warner textbook. And what I did was I scanned and made a copy of page 1053 because it has the z-score that I used for an example to show you how to calculate a z-score for questions 2 and 5 for assignment 4. And the z-score that we're interested in for this particular assignment is a z-score of 1.58. So let's look at how the z-table can be used. Once we know what our z-score is, we find the z-column, and we just go down that z-column until we find the z-score that we want. And in our case, we want to look at the z-score of 158. So what I'm going to do is I'm going to mark that so that we can keep track of it. I'm going to use this red line. Now, this z-score of 158 is equal to a raw score of 74. And the example I used were the raw scores for the final grade. So a z-score of 1.58 is equal to a raw score of 74 in terms of final grades. And when we calculated the mean for the final grades, the mean was about 61, a little over 61. And so the mean is always centered in the middle of our distribution. And by definition, 50% of the scores will fall above the mean and 50% of the scores will fall below the mean in a normal distribution. Now, a normal distribution is cumulative, so the smaller scores are on this end and the larger scores are on this end. And it's cumulative in the sense that it ranges from proportions of scores, or it captures from the smallest proportion of scores all the way up to 100%. So 50% of the scores are above the mean, 50% of the scores are below the mean. Now, where does this score fall, this z-score? The z-score falls right at the edge of this shaded portion. And so I'm just going to mark that. So this is where our z-score of 1.58 is located. Now, this raw score of 74, which is equivalent to a z-score of 1.58, one way to interpret it is that that raw score falls 1.58 standard deviations above the mean. So it's above the mean, and it's positive. Now, this shaded portion represents this number here, 0.0571. Now, these are proportions, or they're percentages. So if we multiply this by 100, we can say that this shaded portion represents 5.7% of the scores in that distribution. The other thing we can say is that 5.7% of the scores in the distribution are above a z-score of 1.58 or a raw score of 74. So what percentile rank does a raw score of 74 represent? Well, when we convert that raw score to a z-score of 1.58, then we can calculate that. And so what we can do is we can take 1 minus 0.0571, and that's equal to 94.29. So what this means is that a raw score of 74, which is equivalent to a z-score of 1.58, falls at or just above 94% of all the scores in the distribution. 5.71% fall above. So this percentile rank then for the z-score of 1.58 or the raw score of 74 is the 94th percentile. Now, in question number 5, I used a raw score of 49. Now, if we know that the raw score of 49, we know that's below the mean. Okay? And so that's the equivalent of a z of negative 1.58. So now, if I look at this part, this graph, and I get the mean centered, or a line representing the mean. The z-score here, because it's negative, is now at this boundary of this smaller portion. So for a raw score of 49 for a final exam grade, that's going to be below the mean. The mean is 61. That's going to be down here. It's below the mean, so it's negative. And what it means is that this score is falling at or above 5.7% of all the scores. And that 94 or about 94.3% of scores are above a z of negative 1.58 or a raw score of 49. So this is how the z-table can help you in terms of calculating percentile ranks and determining the position of raw scores relative to other scores in the distribution. A word of caution is that in order to use these percentages or these proportions, the curve needs to be, or the data needs to be, normally distributed. I hope this helps. Please let me know if you have questions. Thank you.